Hello everyone. Very good evening. Myself Sajan Kumar. Here today we will be discussing about electric vehicle and especially this thermal part of the electric vehicle, like thermal management of an electric car. We are starting this session. What topics will be covering for today? That will be the introduction to electric vehicles, then comparison of IC like internal combustion engines and electric vehicles, and introduction to sales used in electric vehicles, introduction to electric vehicle thermal management, and methods of battery cooling. So these will be topics we will be covering for today. So this is a electric vehicle, like electric car. This is so I will be just introducing few parts about this. Uh, if you see this, this is a battery pack. So this is the major thing that on that this complete electric vehicle technology is relies on that. So this is the battery pack. In backside there is a motor, and in front side some electronics and HVAC systems are there. So these three four are major parts of an electric car. So if I try to define an electric vehicle, so an electric vehicle is a vehicle which uses traction motors for propulsion, which get power from either external storage or internal storage system within them. So what is happening now? Suppose a car which have a internal storage system battery pack and running on the road, that is the electric vehicle. But there are some electric vehicles which are having this storage system outside. A very good example of that is Indian Railway. Like railways today, 90% railways in India has been electrified now. So those all are also running on electricity, but the only difference is that their storage system is outside. They are not within the railway. So that is also electric vehicle. Just a simple difference is that their storage system is outside. So today we will be not discussing about the vehicle who having this storage system outside. We will be discussing about only complete battery electric vehicle, like the vehicle which have their battery system inside them, like electric car. So how it's going on? So initially it start with the cell. We have a cell, and number of cells used to get make a module, and number of modules used to make a pack, and this pack used to get assembled in a car, and that makes them a electric car. So there is a cylindrical cells, very popular one at 650 cylindrical cell from Panasonic. Tesla is this earlier version of Tesla. We are using this cell. Now in second picture there is a pouch cell. Then again few pouch cells used to make this module. Again few modules used to make this battery pack, and again this make a car. So this is the basic concept how a small cell used to make a huge storage system, and then this used to operate a car. So, like why EV? Why electric vehicle is important? So there is a simple comparison between an IC internal combustion engine and electric vehicle. So what disadvantage there are in heat engines or IC based engines that is forcing us to move to electric vehicle. So first will be complex, heavy, big, and expensive. The all the heat engines are very complex, heavy. They are very big in size and they are very expensive. Their maintenance is very high and they used to wear out very shortly. And in terms of energy, they are 75% not like efficient. Only their efficiency is 25%. And in terms of if we talk about supercars like Bugatti Veyron, in that case it is 90% not efficient. Only 10% of energy has been converted to their BHP, brake horsepower. So this kind of inefficiency are there in heat engines. They don't run on renewable kind of energy like solar or wind. So they always use this fuel like conventional fuels, petrol, diesel, and all. So they can't rely on this non-conventional energy resources like solar or wind, which are very pure, which are not hazardous to our this earth. And unhealthy exhaust, their exhaust like SOx gases and COx gases are exhausting from their exhaust system. They are not healthy for the human being. And every liter of gasoline produces 2.3 kg of CO2 gas. So these all are a major disadvantages of heat engine, which forces the human on the earth to switch to the electric vehicle. Now, like, what advantage with an electric vehicle? So in an electric vehicle, the major part which used to rotate the vehicle, that is electric motor. And here I will be telling you some advantages of electric motor. That is only one moving part. The first, they have only one rotor, no extra moving part. So very less chance of wear, tear and all. Then very light, compact, simple, no maintenance and inexpensive. They ideally or essentially they last forever. Their efficiency is also close to 100%. So motors are always have this efficiency around 95%. So this close to 100% efficiency is making us to use this more and more. And in this electric vehicle, braking can also use as a energy source. So we can use this braking to charge a battery. Then much better acceleration. In terms of acceleration, they are very good. Can run on renewable energy resources, like we can charge our electric vehicle by solar power plant, wind energy and all. No exhaust gases. So these electric cars, they don't have any exhaust, no hazards, no hazardous gases. So it is very like good to use to save our earth for our future generation. Now we are moving to this introduction to cell used in EV. So which kind of cells people are using in the industry for to make a battery pack or to make a electric vehicle. So normally people are using pouch cell, prismatic cells and cylindrical cells. So these three type of cells mechanically people are using to make a battery pack for an EV. So now coming to our main focus point for today, that is EV thermal management. So from now we will be discussing about this thermal management of electric vehicle, why it is important, where from where this heats and all is coming in an electric vehicle, and what happen if we will not manage this thermal. So coming to the point, why EV thermal management is important in an electric vehicle. First, for passengers' comfortable ride. So suppose you are moving in a car and inside the cabin you have 40 or 50 degrees Celsius temperature. So in that condition you will not be feeling comfortable. So you will need an some meaning of source which manage your car cabin temperature. So this thermal management of car cabin is important. So why so? Because to ourselves, like pleasant ride. So like today, this pleasancy is very important. Okay, if I am riding in any vehicle, I should be comfortable. So that is the one point why thermal management is important in a car. Second one, to keep battery pack under optimal temperature range and within an acceptable temperature area. So what going on for every lithium ion cells are there. So for those cells, the manufacturer who manufacture those cells like LG is there or Panasonic is there or Samsung is there. So these companies are making these companies are making this cell, and they are telling on the basis of their research or their experiment if we maintain the temperature of cell within this temperature range, then in that condition battery will give their 100% efficiency, 100% performance. If we go beyond that temperature range, suppose if we go low, if we go high, in both of the condition, their efficiency, their performance, all will get lost. So that is the reason thermal management of an electric vehicle is important. Third one is record the state of the battery and detect critical points for battery failures and transmit alarm messages. So what will happen? These all cells are working on the chemical reactions within them. So we always have to monitor ki some everything is going fine. If something is going bad, we have to monitor it and we have to stop it. So there is a term called in industry called corrective and preventive action. So suppose any point is there where we can, some places are there where we can take this corrective action. Some places are there where we can't go for corrective action. Anyhow, any case, we have to do the preventive action itself. That is same applied to the electric vehicle and especially in battery pack. In battery pack, we can't do the corrective action. Anyhow, any condition, we have to do the preventive action. So if something happen, no, it should not be happen. Before something happen, we have to cure it out. So for that also this thermal management of electric vehicle is very important. Fourth one is suppress thermal runaway propagation. So you all must heard about this. Initially, when few electric vehicles have been launched worldwide, so they start cutting fire in case of intense heat. So that is why that was happening. That was because of thermal runaway. So I will be explaining you especially what thermal runaway in our like next slide. But like in thermal runaway, it this cells or the battery pack used to blast like a bomb. So that causes fire in the vehicle, and that is very hazardous condition. So that cost of life of a human being. So that is the also a reason to why we should thermally manage an electric vehicle, and to keep the traction motor at optimal working temperature. So apart from car cabin, apart from battery pack, this thermal management of motor and electronics devices in an electric vehicle, that is also very important, because these all electronics accessories and devices, they also have some temperature range. If they are working on that temperature range, their performance they will be good. If they got lower than that temperature, or if they got higher than that temperature, in both of the condition their efficiency, their performance will get decreased. So there are 4 points. First one is car cabin. So in an electric car, this car cabin, their thermal management is important. Second one is traction motor. Third one is power electronics, whatever electronics devices like DC to DC converter, AC to DC converter, and this various this inverter for the motor. All those electronics devices are there. So all those things should be thermally managed. And this is battery pack. So in these four devices, this battery pack, we should take a special care of thermal management of this battery. So coming to the battery now. So what if the battery is too cold? So I'm like there are two conditions. So one is lower temperature effect of the battery, and second one is higher temperature effect of the battery. So what will be happening if there is a lower temperature effects on the battery? So suppose there is a lower than 5 degrees Celsius. Suppose the battery temperature is lower than 5 degrees Celsius. In that condition, this fast charging will not be happen. So what is fast charging here now? So you must be heard about that. Suppose I have an electric car, so depends upon their this storage capacity, battery power capacity. Some vehicles are taking 5 hours to get full charge, some vehicles are taking 6, 7, 8 hours, depends upon their battery capacity, if we are doing it charge at our home or office. But if we are going for the fast charger, so in that condition, DC to DC charger is there. So in fast charging condition, it is to get charge in half an hour or 45 minutes. That's all. So if the temperature of the battery pack is lower than 5 degrees Celsius, in that condition, we will not be able to fast charge the vehicle. What will happen if the temperature is 0 degrees Celsius or lower than that? So in the condition when the battery temperature is lower than 0 degrees Celsius, like in conditions like USA or European country, they have few months in that the temperature is very low. And if it is happening like that, in that condition, battery will lose the charge, lose in power, acceleration and driving range. So like thermal management of this battery pack, that doesn't mean only cooling down the battery. We can't cool beyond a limit. So those all limits are described by the manufacturer of the cell. So there is a point ki we have to keep this battery pack temperature in a some range. So we can't go beyond that. Like we can't make it too hot, or we can't lower than the value. Like we can't too cold that. So this was the lower temperature effect. What is higher temperature effect? Suppose our battery temperature is get high. In that condition, what will happen? So suppose there is greater than 30 degrees Celsius temperature of the battery pack. In that condition, it will degrade the battery performance. Second, what will happen if this battery pack temperature is higher than 40 degrees Celsius? In that condition, there will be some serious damage. There could be a irreversible damage, which cannot be reversed again. So some irreversible damage will be there. And if there is a temperature which is greater than 150 degrees Celsius, in that condition, 100% there is a chances of thermal runaway. and thermal runaway is a very hazardous condition in case of electric vehicle. So anyhow, we should not we should keep this thermal management in such a way. See, this battery pack could not reach that temperature. Now coming to the point, what thermal runaway is. So in case of battery, in case of cell, there are three kind of abuse are there: mechanical abuse, electrical abuse, and this thermal abuse. So in mechanical abuse, what will be happening? So suppose the car got accident or something like that happen, then this battery used to get crushed or punctured. So that is mechanical abuse. Second is electrical abuse. So electrical abuse means overcharging or the over discharging. And third one is thermal abuse. So the temperature of the battery or the cell it goes to overheated. So in these all three abuse condition, mechanical, electrical, and thermal, this will be a region of thermal runaway. And in thermal runaway, the battery will explode out. And once one battery will get explode out, it will propagate to the their adjacent cells. So and this all the vehicle will get explode out. So that is the reason thermal management of an electric car is very important. Now coming to the point, what see? So I told you. So in mechanical abuse, okay, we can make a car something like that. We structures and all. In case of any accident, it should not be reached to the battery pack at least. Similarly, in case of this electrical abuse, so what we will be doing? We have some battery management system and all, which are taking care about this overcharging and over discharging of the cells or the battery pack. But in case of thermal abuse, what will be happening? There is a thermal management system of the battery pack which will take care about this. So we will be discussing about that thermal part of the. So what causes the heat source in a battery pack? First, fast battery charging. If we do the fast charging of the battery, like at the supercharger station or the fast charging station, at that time there is a enormous amount of heat has been generated, and their management is very important. Second, local electrode over potential. So some every cells are having electrodes, this cathode and anode. So some electrodes got the over potential. That is the also a reason to this heat source of the battery pack. Some cells have the entropy of the cell reaction. So when there is a reaction in the cell, that only causes the current flow of current in a battery cell. So suppose there are some defects in that condition also, this battery pack will generate the heat source. And fourth one is on their main reaction, like in each and every cell, there is a chemical reaction happening which generates the energy inside the cell, and we are using that energy to run our vehicle. So apart from main reaction, some side reactions are also there, which also causes some heat source in a battery pack. So those all were the heat source of a battery pack. Now what we can do to control those all heat source? So we have some methods of cooling of battery pack. So we have four methods of cooling of battery pack. One is air cooling, second one is refrigerant cooling, third one is liquid cooling, fourth one is PCM, phase change material cooling. So we will be discussing one by one each of those. So air cooling. So you can this battery in air cooling, the battery is cooled by air either by direct exposed to the environment or by the fan. So here you can see there is a huge battery pack, and there is a huge fan is there which is blowing the air inside, and you can see this blue line. So this blue line is cold air, and when it goes into the battery pack, it take the heat from the battery pack and it get warm. And this red line is a hot air, so it coming out. You can be able to see here. So this is the way this air cooling works. So in air cooling, two things is there: either we can direct expose to the environmental air, that is applicable to the small battery packs like 1 kilowatt, 2 kilowatt, or 3 kilowatt. When there is a large battery packs for a car or for a commercial vehicle, in that condition we can't rely on the environmental air itself. So in that condition we have a forced convection of air, so by a good fan or a huge fan, so it is blowing the air inside and it's coming out. So that is the way we are cooling the this battery pack by the air. Second method is refrigerant cooling. So some vehicle have a high, like huge battery packs, maybe 90 kilowatt hour, 100 kilowatt hour, or more than that. So in that condition, we can't rely on this air cooling system. So in that system, see, this is the battery pack for the BMW i3. So what they are using refrigerant cooling system. So how this is happening? So refrigerants are directly passed through the passenger inside the battery pack to cool the battery. So how it is happening? Here, batteries are not there. Only passages are there, and between each two passages, batteries are there. So how it is happening? There, see, this is the unit coming from the HVAC system, and there is a small tubes are there. So from this small tubes, this refrigerant is coming, and this is flowing like that, and then again here is collecting and going back to the refrigeration system. So in that way, when this refrigerant is passing through this all, it is like a situation of evaporation. So it sucks the heat from this battery and move forward, and that is the way we are cooling this battery pack in terms of refrigerant cooling. Next one is liquid cooling system. This is the most favorable and most reliable technology people are using nowadays in electric vehicle industry. That is called liquid cooling indirect. So what will be happening here? The small tubes are there. So I will be telling what how it is working. So the cooling fluid first get cooled by the radiator or HVAC system, and then it further passes through the cooling tubes to cool down the battery pack. So here you can see there is a battery pack, and beneath that there is a cooling plate is there. And if you go in detail of the cooling plate, so this is the in detail of plate. So uh, in between the cooling plate there is a small tubes are passing through. So by that cooling tubes, we liquid this coolant is going through that, it cooling down this battery pack, taking away their heat and comes outside. So that is the way this liquid coolings is to work. This is the picture of this Chevrolet Volt cooling system. So Chevrolet Volt are using this liquid cooling system as their cooling system. Next one is liquid cooling by immersion. So in this, the cells are directly immersed in a tray containing high dielectric and non-conductive cooling fluid having a high boiling point. So how it is happening? We have a tray in which these cells are there, and these cells are immersed in a cooling fluid. So you can see this module case, then battery cell and liquid. So liquid are there, so these all cells are dipped into that, and there is a reservoir and pump operating system. So like this from reservoir the pump is sending up the cool liquid into that, and the hot liquid is coming out. So that is the way this immersion system of liquid cooling system is working. So there is a company called 3M. They are in this material science. They are a very big company in terms of materials, adhesives, and all. So they just recently they launched their liquid called Novec Engineering Fluid. So this Novec Engineering Fluid the people are using nowadays for this immersion liquid, which is very good in high dielectric strength and very non-conductive cooling liquid is there, as well as there this specific heat capacity is good so that it can cool down the batteries. And the last one is PCM, phase change material. So how it's happening in phase change condition? So there is a material which is called PCM, phase change material. So see, you can see there is a battery pack and a small, these cells are there, and apart from cell, there is a black color material is there. So those all are phase change material. So how this is happening? The cells are surrounded by the phase change material, which absorbs heat while melting from solid to liquid, and then releasing the energy while again getting back to solid. So how those all are working? So suppose our vehicle is running, charging or discharging. So in that case, the cells, the battery will be generating the heat, and this PCM material will absorbing the heat, and they will change their state from solid. It will be get in semi-liquid condition, and when will we stop using the vehicle in that condition, it will release this their temperature to to the environment, and they again will get in solid state again. So that is the like where this PCM is to work. So there is a like comparison of different cooling system. There are air cooling system, In air cooling system, the fan cooling system is there, phase change material condition is there, liquid cooling system is there. In liquid, there are two type of cooling system, direct and indirect. In direct, this battery or cells are directly emerge into the liquid. In indirect cooling system, there is a flowing tube or flat tube, like depends upon the different design. There is a tube which is like passing through which each two rods of the cells, and they are like taking the heat from the cells, and liquid is flowing away. So that is the liquid cooling system, phase change material, fan cooling, and air cooling. So you can see the 50% of the technology is captured by this liquid cooling system itself. This air cooling, fan cooling, and this phase change material, they are very like less used in comparison of their counterpart. Why? Because this liquid cooling system is most reliable, and we can trust on that. Phase change material is used where there are some limitations. We can't go for the huge battery pack. Like if you have up to 5 kilowatt or 10 kilowatt hour battery pack, then you can go for the phase change material. Higher than that, I personally will not suggest to go for the phase change material condition. Fan cooling is people are using in car as well, but what this drawback is with the fan cooling system, they in that condition we have to uh, carry extra load in case of fan cooling system. So this is not preferable in the industry. And this air cooling system people use in especially in electric scooty, electric bike is there. In those all condition, people are using this air cooling system. So any questions? Hello, hello.
Sir.
Yeah, I'm audible to everyone.
Hello. Yes, sir, you are audible.
Yes, yes,
So,
yes.
guys, if you have any question, sir, I have one question.
Okay, tell
Hello.
me.
Hello.
Hello. Yeah, tell me.
Yes, sir. I want to start my career in electrical vehicle industry.
Okay.
So, what path will you suggest in starting of my career?
So you have completed your engineering.
Yes, yes, yes.
Okay.
I
So
mean, I
at
am a fresher, but I want to start my career in electrical vector sector. So, what path
okay.
will you suggest in starting of career?
See, the thing is that electric vehicle industry is like a very complex industry. Like in terms of IC engine, the technology is very saturated. So there are people who can train you, but in when you go for the electric vehicle industry, even though in big companies also there are people not well experienced. So like they don't have time to train you. So what people are doing, so they are not hiring freshers because, like honestly speaking, in our college curriculum till now, I don't think the electric vehicle are in our college curriculum. This is not there. I think so. So how people you can like do any you can go for some this research part ki, okay, have a brief study about this electric vehicle industry, how this is going on. If you are a mechanical engineer, then focus on this mechanical segment of the electric vehicle. If you are electrical or electronics engineer, then focus on the this electrical segment of the that, gather some knowledge, and then try to switch on that. So initially you can strike with some few startups. So you can go with the startups because they usually cope up with the pressure. So you can go with the pressure startups, gather some knowledge, invest your 1 or 2 years there, gather some experience, and then you can proceed your career further.
Sir, what are the software required in starting of my career?
So any software is fine. See, the thing is that in terms of software, software is never ever an issue in any company. Why so? Each and every software is looks like similar. Their user interface is approximately similar. You have a strong command on any software. and each and every company are using different software, so you can't be experienced in all those software. So for example, like Ola, they are using NX. For example, Sun Mobility, they are using Creo. For example, suppose other industry, they are using Katia. So different companies are using different software. So software is not a concern. Be focused, gather, like be strong in one software. Rest of all, you will be doing that.
Sir, one guy asked, how is the temperature of battery packs maintained in cold places where the temperature is below 5 degrees Celsius?
So that is the point. Thermal management of electric vehicle. That doesn't mean ki we are cooling only. There is a system of heating itself. So what will be happening? So suppose there is a HVAC system and this cooling tube is there. So cooling tube is flowing to the battery pack and there is a coolant or liquid which is flowing inside that. Parallelly, there is a heater, electrical heater. In industry we used to call it PTC heater. So that PTC heater in the loop which is parallelly connected with that. So suppose there is a cooling required. In that condition, only HVAC system will be operating. When there is a heating required, then in that condition sensors are there which sense that and stop this cooling system and it operates the heating system. So in heating will follow on, like that we used to maintain. If you
Okay.
go in detail of that, if you go in detail of that, there is a architecture of whole cooling system of that. In my laptop it is not there. So in future, like you all be always
In live process, we'll discuss that.
yes, yes.
So one more question there. So due to pandemic corona,
Mhm.
all the industry were affected in terms of jobs. So what is the market scenario in electrical vehicle in pandemic situation?
Okay, so what is happening now? So for if we talk about the future, like Earth is there, only Earth we have, fine. Only one Earth we have to live.
Yes.
So and due to global warming and all this, all things going like bad effect on the Earth. So what government are doing right now? They are pushing up this electric vehicle industry. You must be heard about that. Right now there is a campaign. Each and every state government is running a campaign to switch to the electric vehicle. So obviously there is a huge demand and boom in the field of electric vehicle.
Exactly. That means the jobs are there in market. We need
Yeah,
the proper skill set to manage
obviously,
the jobs. Is it?
obviously in terms of electric vehicle there are jobs. You just have to go to the right right place who will show you the path ki where are the jobs.
Okay. Thank you. Any question, guys, from your side? In liquid cooling system, what is the name of coolant used?
So normally people are using 50% liquid glycol and water.
Okay. Any more question, guys? Okay, sir. I think we have done up with the question and answer session.
Okay.
So, on behalf of all Skill India team, I would like to send a very happy word of thanks to you for excellent and informative session. Guys,
Okay.
before ending today's session, please fill the feedback form. The link has been shared in the chat section. And please visit our website for more details. And feel free to contact us anytime. Waiting to see you all in our live session. Thank you, sir. Thank you all for attending the session.